Today we're going to take a look at an extension of the distributive property, and we're going to be multiplying polynomials by polynomials. Before we had multiplied monomials by binomials, and we used the distributive property where we take the factor outside the parentheses and multiply it by each term in the parentheses. But here we have a binomial times a binomial. Well, essentially we need to do the same thing. We need to apply the distributive property twice. We need to multiply the 2x times the 3x plus 2. And we need to multiply the 5 times the 3x plus 2. And then I'll actually use the distributive property. Multiplying 2x times 3x, I get 2x squared. And then 2x times 2, I get 4x. And then distributing the 5 with the 3x, I get 15x. And distributing the 5 with the 2, I get 10. And then we have two like terms here, the 15x and the 4x, so we can combine those. And our final answer for this, when we multiply 2x plus 5 times quantity 3x plus 2, our final answer is 6x squared plus 19x plus 10. Now, some of you may have already been exposed to this word to describe multiplying a binomial times a binomial, FOIL, and that stands for first, outer, inner, last. So if you notice, we multiplied the first terms together, we would have 6x squared. If we multiply the outside terms together, the 2x times the 2, we have this 4x. Then if we multiply the inside terms, the 5 times the 3x, we get 15x. And then last but not least, we multiply the 5 and the 2, and we get 10. You could do that if you want. The main thing, rather than remembering the word FOIL and what it stands for, is that you have to realize that 2x is multiplied by everything in the second set of parentheses, and the plus 5 is multiplied by everything in the second set of parentheses. Let's take a look at another example. We need to multiply the 3x times what's in the second set of parentheses. So we're going to have 3x multiplied by 2x, and then the 3x multiplied by 1. And then we're going to have the negative 6 multiplied by 2x, and the negative 6 multiplied by 1. So 3x times 2x gives us 6x squared. 3x times 1 gives us 3x. Negative 6 times 2x gives us a negative, or we can say minus 12x. And then last but not least, we'd have a minus 6. We have like terms here that we can combine. When we combine those, we get 6x squared minus 15x minus 6. So you could use FOIL and remember first, outer, inner, last to multiply those together. However, that will not work when we take a look at a problem like this, when we have a binomial, two terms, multiplied by a trinomial. So what we need to do here is just make sure we multiply the 2 times each term in the second set of parentheses. So 2 times 3 gives us 6, and then 2 times 5x gives us 10x, and then 2 times a negative 4x squared gives us negative 8x squared. So I multiplied the 2 times each set of terms in the second set of parentheses. Now I'm going to do the same thing, but now I'm going to multiply the negative x times each of these terms. So negative x times 3 is going to give us a negative 3x. And I'm going to write that underneath our 10x so that when we combine like terms we can do that easily. Then we have negative x times 5x. That's going to give us negative 5x squared. And then negative x times negative 4x squared. Be careful here, that's going to give us a positive 4x cubed. X squared times x to the first gives us x cubed. Negative times negative gives us a positive. And now what we're going to do to finish up here is we're going to combine like terms. So our final answer here ends up being 6 plus 7x. 10x minus 3x would give us 7x, minus 13x squared plus 4x cubed. I'm just adding here the first row and the second row to get our final result. This is what's called ascending order. Notice the exponents are 1, 2, 3. That's ascending order. If you wrote them in descending order, then we'd have the x cubed listed first. 4x cubed minus 13x squared plus 7x plus 6. That is descending order because our exponents are going down 3, 2, 1, and then actually an x to the 0 here. Descending order. Does it matter to me whether you write your answers in ascending order or descending order? No. It's perfectly fine to leave your answer in ascending order if that's how you ended up arriving at your answer. Let's take a look at one last example. Here we've got an equation where we're going to solve for x. So we need to distribute, take the x times both x and 3. So we'll do that first. So we're going to have x squared plus, because that's x times x, x squared, x times the 3 plus 3x. Then we're going to take the 4 times the x and the 4 times the 3. So when we do that, we're going to have plus 4x, and then 4 times 3 is 12. Don't want to forget about the right-hand side of the equal sign here. We're going to take the x times the x and the x times the 5. So x times x gives us x squared. X times 5 gives us 5x. And then we're going to multiply the 1 times the x and the 1 times the 5. The 1 times the x and the 1 times the 5. 1 times the x gives us 1x. I'll put the 1 there for emphasis, although we technically don't need that 1. And then 1 times the 5 gives us 5. Right, let's combine like terms. I'm going to change to red here. We'll combine like terms. We're going to have x squared plus 7x because the 3x and the 4x here are like terms. So keep going here. We have plus 12 equals x squared. And once again, we have some like terms here, 5x and 1x. That would give us 6x. And then we have plus 5. I'm going to subtract x squared from both sides. And notice when I do that, the x squared terms cancel. So we're left with 7x plus 12. And that is equal to 6x plus 5. I'm going to subtract 6x from both sides to get the x by itself. So we have x plus 12 equals 5. So that means that x is, when I subtract 12 from both sides, I get that x is negative 7. And we can check our work here by substituting negative 7 in for x. So we'd have negative 7 plus 5 and negative 7 plus 3. And we need to see if that is equal to, I'm going to put a question mark here for now until we know for sure. We need to see if that's equal to negative 7 plus 1 multiplied by negative 7 plus 5. And it is not. That is interesting. So where did I make a mistake? Don't see any mistakes there. Don't see any mistakes there. That's kind of interesting. Alright, I found my mistake. I had to pause it and take a second to think. Right here, this should not be negative 7 plus 5. This should be negative 7 plus 4. So this would be negative 3 times negative 4, and we need to see if that's equal to negative 6 times negative 2. Does 12 equal 12? The answer is yes, so the solution works. So we solved it correctly, but we had a little bit of a problem with our check. So it's important that you really are careful when you do your check. So don't forget to do your survey questions at tinyurl to see if you understand these concepts.